Hello everyone, we're Lin Shi and Zihan Liu. Today we're excited to introduce a groundbreaking study titled An Image is Worth a Word, Personalizing Text-to-Image Generation Using Textual Inversion. This paper tackles a fascinating problem. How do we teach a computer to understand and generate images from highly personalized concepts? Think of this iconic scene from Titanic, where Rose asks Jack to draw me like one of her French girls. This simple request carries deep implications. It's not just about drawing Rose, but capturing her in a style reminiscent of Jack's previous works. It's about the specificity and uniqueness of the subject me, Rose herself. This scene perfectly encapsulates the challenge this paper addresses, enabling a machine to interpret and visualize such nuanced, personal requests without extensive retraining. The significance of this work lies in its novel approach to integrating personalized concepts into pre-trained models, offering unprecedented creative freedom to users through a simple textual interface. Before we delve into the novel approach presented in this paper, works prior to this study have proposed that introducing new concepts into large-scale models is often difficult. Retraining a model with an expanded dataset for each new concept is prohibitively expensive, and fine-tuning on few examples typically leads to catastrophic forgetting. More measured approaches freeze the model and train transformation modules to adapt its output when faced with new concepts. However, these approaches are still prone to forgetting prior knowledge, or face difficulties in accessing it concurrently with newly learned concepts. To overcome these challenges, the authors proposes textual inversion, a technique that involves creating pseudo-words for specific concepts by optimizing word embeddings directly in the latent space of a pre-trained text-to-image model. This method allows for seamless integration of new concepts into the module's vocabulary, enabling personalized image generation without affecting the model's overall performance. Specifically, they overcome these challenges by finding new words in the textual embedding space of pre-trained text-to-image models. They consider the first stage of the text encoding process, as shown in the figure. Here, an input string is first converted to a set of tokens. Each token is then replaced with its own embedding vector, and these vectors are fed through the downstream model. The goal is to find new embedding vectors that represent new specific concepts.
Let's now look at some key results from the study. On this slide, you can see several examples that shows their method for generating a wide range of image variations from a single input concept. Starting from the top left, they use a pseudo-word denoted as star to transform a standard object like a skull mark into various interpretations while maintaining high fidelity to the original concept. The input sample on the left column shows the starting images, and the row labeled hours display the author's model output, which capture complex details and variations. But further, when comparing their results with output from DALL-E 2 using image inputs, the author methods not only provide more faithful recreation, but also enable a richer exploration of creative style. For instance, the transformation of the skull mark into different artists' interpretation showcase their model's flexibility. Moving to the right, you can see the transformations such as an oil painting of star, app icon of star, and even complex scenes like Amo sitting in the same pose as star. Each column demonstrates the powerful adaptability of the author's method to various artist style and object transformation. And the bottom section of the slide displays further versatilities by taking diverse objects and reimagining them in different settings, such as the street of Paris in the style of star and an adorable corgi in the style of star. These examples demonstrate the model's ability to infuse artist style into everyday scenes and objects. And to summarize, the key takeaway message of this paper is the innovative use of textual inversion to personalize text image generation. With the help of their approach, users can integrate a unique and specific concept into a pre-trained model, expanding creative possibilities without the need for extensive model retraining. And for more details about the methodologies and more interesting examples, you may take a look at their papers and explore the GitHub repository through these links. Thank you for listening.